Think we're live. All right. Hello world, it's Siraj and welcome to my live stream. In this live stream, we're going to be talking about TensorFlow Extended. We're going to be talking about the entire suite of tools that TensorFlow offers you because, as we move into the final week, we are going to be working on projects that are more and more comprehensive. That means that it's not just that we're training models, or it's not just that we're testing models, but we're also serving them in a web app, in a mobile app, in some sort of app that users can actually use. So I want to start off with asking some questions, with answering some questions, and then we're going to move on to a little bit of TensorFlow serving theory I have to talk about, and then we're going to move into data transforms, which I haven't talked about yet, but I'm excited to talk about. All right, so let's start with the Q&As. What are the questions? Hi Sam, I'll get back to you via email if you email me. Any questions about TensorFlow, about any of this stuff? What do we got? Hi Sam, I'll get back to you. Would you show us how to incorporate in our web app something that gathers data on our users? Yes, actually, Camille, that's exactly what I'm going to show you in this live stream. I was predicting that this is something that, I was seeing how a lot of students had these issues, and that's why I wanted to talk about it in this live stream. Uh, Gopal, I will. Yeah, it's obviously, yes. I understand. It's unfair. I've revoked access for most of them. I still have some I need to get. I will do that this week. In Europe, no. It's U.S., but the thing is, remote is usually allowed for a lot of them. Please show how to convert models to TensorFlow Lite. Um, okay. Let me. I mean, the converting models to TensorFlow Lite is Onyx, by the way, which we've talked about. But let me just answer that question right now. Onyx is how you convert a model from one type of machine learning library to another, including TensorFlow to TensorFlow Lite. Actually, TensorFlow themselves have a converter, a built-in Lite converter that we can use if we don't want to use Onyx. Right here, it's called TensorFlow Lite Converter, and it's a command line tool. Yeah, I like the command line tool right here, TF Lite Convert. So we can just do this from command line. Shoemake, you will share a sheet where we need to share if we want to get into consulting or startup. When will that happen? It's going to be sent to the people who submit the final. So you have to submit the final, and then I send it. How to load a big data set using TensorFlow? Great question, Nat. So a big data set using TensorFlow. There's different ways to load data, and there's different methods to load data. We can load data as batches. We can load data all at once if it's a small data set. We can load it, the size of the batches we can convert as well. So there's not one answer to that question, but in general, we want to use one of the TensorFlow. We're going to continue to use the TensorFlow extended set of tools for data preprocessing, which will allow us to load data, process data, transform data, all of that stuff. It's a collection of libraries. Will you continue to live stream for guidance in our final projects after week 10? No. Week 10 is the last week for live streams, but I will be doing office hours this week and next week. When will you get feedback on the midterm? Still waiting, Stefan. If I didn't send you the midterm grade yet, then expect it within 24 hours. There's still some that I haven't sent back yet. It's been quite a challenge grading those midterms, but yeah, I got a lot of them out, and I hope to get the rest of them out this evening, my time. Is transfer learning with GANs possible? Yes, it is possible. Transfer learning with GANs is, I mean, think about this. Any kind of model can be transfer learned. I mean, what you're trying to do is, if you think about a GAN is still a set of neural networks, right? It's still the same kind of architecture. It's just that they're dueling against each other rather than being a feed-forward network. So what that means is that these networks still have embeddings. They still have learned representations that we can use as seeds for new models for transfer learning. So it's all about using those embeddings, and those embeddings turn out to be weight files, and they turn out to be pickle files. They turn out to be ONNX files, all sorts of files like that. So we just have to complete the same transfer learning process we always would, but with the embeddings from a GAN. Okay, so that's it for this initial Q&A. Any new midterms? Yeah, I mean, there's people have submitted some, but are you asking me to share them or? Okay, so that's it for the Q&A. Now let's go into a little bit of the lesson for this live stream. So let me make sure this is big enough that we can all see it. Okay, cool. All right. Nishit, if you didn't receive grades yet, just give me 24 hours. You will receive them, okay? So I want to start off with talking about TensorFlow Extended. This is something that a student was asking me a lot about, and I think it's a great thing to talk about. So when we're building these projects, when we are building the midterm, the final, we don't really need TensorFlow Extended. We don't really need this validator. We don't really need the schema generator or the transform or the trainer or the evaluator or the model evaluator. All we really need to see is the serving client, right? All we need to really do is train it and serve it with TensorFlow serving. So that's TensorFlow serving or JS or Lite if we're on mobile, any one of these. That's how we actually serve those models. But then to train them, we used standard TensorFlow. All of this stuff, though, we don't really need for these simple web apps where we have static data sets that we pre-train and we put we're going to combine those together, and then what we have to do long term is we have to start incorporating these libraries into our pipelines, right? So how do we incorporate these libraries into our pipelines? What are the use cases for us to do so? So before I have talked about TensorFlow serving, but I haven't talked about it enough, I don't think. So let's look at TensorFlow serving right here. Let me make this bigger. So for context, by the way, let me just say for context, this is a map of TensorFlow Extended. Now this is a suite of tools that we can use on our data. So assume we have our data right here. Then we can apply all sorts of operations and transformations and all sorts of operations to that data in order to serve it. So it's the larger picture, the largest picture in the training pipeline. But now if we look at TensorFlow serving, that's one part of this. So now let's blow up TensorFlow serving. Let's make that bigger. Okay, so now this is TensorFlow serving. This is the architecture inside of that single box right here, okay? So here's how this works. So what happens is, in our apps, in our midterms, we all have trained models, right, that we're serving in a web app, Flask, Django, whatever framework you chose. What happens when we have real-time data that's being piped into the web app? So let's say we have users who are constantly signing up. Let's say we have people who are making new messages. They're sending all sorts of new data streams, images, videos, whatever. And we want to continuously train the model on all that incoming data. That's when we would use TensorFlow serving. What happens is we're going to have an architecture where we have a fully trained model. It's serving people, because they need it. It's in real time serving people. In the background, we have another model that's training on the new data. Okay, so it's training on the new data in real time. When it's fully trained, we will gracefully exit that current model and input the new model, right? And so now it's serving again. And while that's serving, we have another new model that's starting to be trained on the new data. So this process just repeats. You see what I'm saying? So how this actualizes itself as theory is that we have a source file. Now the source file is basically the actual model that's being trained. Now, when we know that we want to start serving it, the system will look for some threshold values, and then we load it up using this loader object. Now, by the way, all of this stuff is happening in the background. We don't actually have to do anything with this. I'm going to show you how to implement this in a few lines of code without even having to deal with the loader and the dynamic manager. But I just want you to know how it works behind the scenes. So when we have our source model, it's loaded up when a certain threshold value is reached. Let's say that's some accuracy metric or something like that. Once it's been loaded, then the dynamic manager will say how many of these do we need to load to perform inference with, right? So should we perform inference with this one? Should we not? Should we what's the version? So that's another aspect to this. Kind of like with Git commits, there are versions to different models. So we want to sometimes serve the latest version. Now, how do we do that? In order to do that, we have a version policy. And once we have the right model, we've loaded it up, we've decided that this is the one that we want to use, then a client will request inference from that model, and that's the servable handle. The handle is the pipe from which the client can retrieve the optimal model that they need. Okay, so that's the idea behind TensorFlow serving. Now, how does this actualize itself? So if we go to GitHub and we search for different TensorFlow serving examples, then we can look through all of these. And I found this really great example that basically shows how TensorFlow serving works really simply. So it's called Serving TensorFlow Model, and it's just a linear regression model in TensorFlow. It's part of this guy's blog post, but basically there are 3 files here. There's a Flask client. We all know how Flask works now. We've learned how that works. Just very simple, define a server, right? And then we have our model. And our model is a standard TensorFlow model. We have our input data, our output data. We have our weight values. We have our loss function. We have all of that stuff. Standard TensorFlow. Now here is the interesting part. We have our client function. Now in this client function, let me make this a little bit bigger. We have TensorFlow serving right here. So what's happening here? So predict and prediction service. Now with these 2 functions, we can access everything that I've talked about right here without even having to, as you notice, there's no word servable. There's no word source or loader. All we do is we are connecting to the server. We are starting the TensorFlow serving service, and then we're requesting a prediction. This is where we create some dummy data, and then we make some inference using that data. So you see what I'm saying? Like, TensorFlow serving is extremely easy to use, even though it's so powerful. In this, it was just 2 lines of code to implement. Okay, so that's that. Now, I want to go back and I want to talk about the data transforming, right? So this transform library is one I haven't talked about. I like to talk about today. So let's see what we have here. So if we go to TensorFlow Transform, I want to show you a collab right here. And we want to go through this one. Okay. You know, I was thinking like I could just like code this out, but I think we really just want to see the outputs. So let's look at the outputs. Running Google Colab. We want to see how this works in general. So let me explain this code as I compile it. I think that might be the most useful thing. So now, you know, a lot of times we have, like I said, we have data of, you know, tweets, we have posts, messages, new videos or whatever that our users post. And we want to transform that data in real time, right? Sometimes you can't train a model on raw video data. You've got to convert that video data into integers. You've got to convert it, sorry. You have to convert it, sorry. You have to convert it into a format that your neural network will accept. Now, how do you do that in real time? The answer is TensorFlow Transform. So, I'll talk about PyTorch in a second. Let's one thing at a time, guys. I had a plan for this live stream. Let me execute it, and then we can go back to that. Okay, so we have transform here. Now, the system and OS, these are just general pre-processing. These are just generic libraries. We don't have to worry about that. And then we have, let me just answer this question right here. When are we going to use PyTorch? We haven't used it yet in this course, only 1 week left. Look, I understand that PyTorch is a very popular library. I like it myself. I have a friend on the PyTorch team at Facebook that I chat with, you know, very often. And we basically came to the same conclusion that while PyTorch is great for research, it's not good for serving. Like there's not a PyTorch serving library. Think about that. If you want to actually make an app that makes money, if you actually want to make a service, you're going to need to serve the trained model. And PyTorch doesn't have that. PyTorch has Cafe 2, which is a different library to help with serving, but it's much harder to get started than TensorFlow serving. So that's why I chose TensorFlow serving for this course. Okay? So PyTorch is not really that much better. It's really just for prototyping scripts alone, like in a collab that PyTorch is a little cleaner and more readable for. Okay, so TensorFlow Transform is its own library, as you can see here. Then we have Beam, and so Beam is basically Apache Beam is it's a part of TensorFlow Transform, and what it does is it's a data pre-processing engine. It's what actually executes the transforms that we want. It's the executor. Think of it that way. It's the executor. Then we have our metadata, and then we have our schema. So the metadata is the actual, like, it's the mapping of what our input is and what types of data our output is as well. The schema is the structure of it. And so once we have that, then we define what our data and our metadata are going to be, right? So this is still very simple stuff. I'm going to show you the cool part in a second here. When we have our raw data, we have X, Y, and S. These are all input features. And then we have our output feature, our output data, the 1, 2, 3, 1, 2, 3, hello world, hello, okay? So each of these has its own output. Now, the metadata basically defines what type of data each of these features are. So we have a float 32 for Y, okay, that's an integer. We have a float 32 for X, those are integers as well. And then we have a string for S, so these are strings. So that's how we define what each of these values are for our model, okay? Now, okay, so we have that part. Now I want to talk about the pre-processing function. So if we go to the pre-processing function, this is the actual good stuff. This is what actually matters. So in this pre-processing function, this is where the actual transformations are happening. We've defined our data. We have imported our libraries. Now this is where the real magic happens. So when we have our x, y, s, remember these are our three inputs, right? Now we will apply our TensorFlow operations to those inputs. Now I want to make a distinction here. We have our TensorFlow operations, and then we have our TensorFlow transform analyzers. These are two different type of functions inside of the TensorFlow transform library. So anytime you see TFT, that means TensorFlow Transform Analyzer. Basically, it's a way to perform an operation on some data, but it happens one time and it occurs across the entire data set. So when we say give us the mean of x, it's giving us the mean of all the values of x. When we say that we want to normalize y, and we want to scale it, when we say we want to scale y to a value between 0 and 1, which is another word for normalization, what's happening is we're doing that for every value of y in the data set, right? So when you have hundreds of thousands of data points, this stuff becomes really valuable, right? Because you don't want to be transforming data yourself manually and then uploading the model and then doing that every 2 weeks or every month, right? When you have new data. You want that whole process to be automatic, and not just the serving, but the data transformation and the pre-processing. So this code is happening server side right here, okay? So when we wanted to get the mean of all of the x values, we wanted to normalize all of the y values, and we wanted to convert all of the s values from strings to integers. Those hello world, we want to convert those to integers. Lastly, we're going to create a new feature, so a fourth feature, which is basically the x-centered times the y normalized. We just multiply x by y, and that's a fourth feature. And that's basically that, adding features can improve the accuracy of our model. It can improve, it can make it faster or, slower. It's basically a pre-processing technique. So once we have that pre-processing function, this is where let me just compile that so we have that. Once we have that, this is where the magic happens. So let me just compile this out. Okay, so what happened here? We had our raw data. We fed it to, we put it into this main function, which encapsulates everything that we've done so far. And then we output this transformed data. Now this transformed data is much easier to process for our neural network. We can just feed it directly in. It's cleaner, and it's just TensorFlow ready. So how did we do that? So what happened here? We said inside of this TensorFlow transform beam context, take three inputs. We're going to take the raw data, the raw metadata, and the pre-processing function. We're going to use beam to analyze and transform the data set. And as a result, we're going to get this transformed data set and the transformed function. And then once we have that transformed data set, we can split it up into the raw data and the metadata, and then we can print out those two. So to clarify, you guys might be like, wait, what's Beam again? So Beam is basically a data processing library. It's a standalone library. Like, you don't need TensorFlow for this. Like, you can just download Beam's SDK, right? You can choose a language and a runtime, and basically it's a way of manipulating and handling big data. But the great thing about TensorFlow Transform is that it's encapsulated this entire library into it, right? So batch and stream data preprocessing runs on any execution engine. They've already built it into Transform. So that's super cool. I'm a big fan of that. So let's go back here. Okay, so that's for Transform. Now I would like to The reason we're talking about this stuff, guys, is because this is the kind of thing that, if you want bonus points on your midterm, I would love to see, you incorporate some kind, like, I don't expect it, but I would love to see you incorporate some kind of TensorFlow transform in real time. If I see an interesting implementation of TensorFlow serving, I'll also be very happy and impressed. Um, This is the graph. This is the computation graph that's returned. So it returns two things. It returns a graph and it returns the transformed data set. And with the graph, we can input the graph again to get into another computation graph, and we can chain them together, or we could just use that transformed data set. Okay, so right. So the point of this is that I want to see um, people use this stuff in their final. You don't have to, but it would be nice to see. You do have to build a mobile app or a web app. That's either the same as your midterm or a different one. So that's always nice to see. Now, when we go back to this, I also want to show you, since for the midterm we do have to do a mobile app. I want to show you how some different examples of some mobile machine learning applications. So first of all, Flutter has a TensorFlow Lite plugin. Sure, let me share the collab with you guys. Hold on. Whoa, that was weird. Oh, hello. I think I just like lagged. Yeah, let me just no, I pasted it as a comment. Okay, so you guys have it as a comment. Okay, great to hear, Capio. I shared it in the comments as well. So okay, so now let me make myself bigger. Let me get back to Q&A. So guys, week 9 is the gaming week, and it was hard for me as I was thinking about ways to make money with gaming. It was hard to think of legitimate ways to make money with gaming, but I think overall there are ways to make money with gaming. You just have to look at supplementary services. So obviously, making a game and making money from that's going to be much harder. But making all sorts of services like being able to have items, being able to create services for players, for if we want to be a little bit more creative, creating generative models for game developers that will 3D objects and character personalities as well with text generation. We can generate different storylines for these games. So that's more the focus of the gaming week. But the last week, week 10, is going to be on the Internet of Things. So combining different models and different devices, how to train models across different devices, across the edge, edge computing, things like that. And then we'll incorporate a little bit of privacy at the end as well. But I mean, starting now, you should already be thinking about your final. You should be thinking about what the topic is that you want to do it on. And, if you want any partners, you should be thinking about that as well. But that's kind of the gist of what I'd like you to be thinking about for the project. All right, so let me go back and let me answer some questions here. Ria, yes, accepted. Sam, the deadline for the final is 2 weeks after week 10. So week 10 is released in 1 week from now. So 5-6 days, and then it's going to be, the deadline is 2 weeks from then. Any other questions, guys? Do we have any other questions? I hope to see you guys in the office hours on Friday. Um, and I Kendaya, how long would you like the extension? Bharat, I've temporarily stepped down because I have some mental health issues that I have to deal with, as you can probably understand, and I'm just not in a place to um, do that. I only care about this course. I only care about you guys right now. I'm not really focused on anything else, and frankly, I can't focus on anything else right now. Keld, update. I'm making an animal classifier phone app. I need to update the model since some users report problem. So, image classification is a solved problem. Kendaya agreed. Image classification is a solved problem. We can accurately detect cats or cows with like 99% accuracy. It just comes down to using the state-of-the-art model. So I would say use Inception v3. Your image classifier, you can definitely get a better accuracy for classifying animals. That one is solved. Rob, great to hear. Kapil, yep. Laura, sure. Angel, sure. Camille, gathering data on our users, that's something that just happens in general when we have a database, when they sign up. The second they sign up, they're giving us data. Even before they sign up, if we have some analytics code or tracking code, we can store that in our database as well with some client-side JavaScript. Okay, guys, that's it for this live stream. It's a little shorter than the other live streams. I have some things I have to deal with, and thank you guys for showing up every week. I really appreciate it, and I look forward to seeing your homeworks. All right, thank you guys.